start directly into it. Today I want to introduce you to our ongoing research project, L3ICHTGLAS, where we try to use thin glass for future facades and make it more sustainable. And yeah, I would like to start with this picture here, which is actually a close-up picture from our demonstrator 2 years ago here on GlassTech. It shows a thin glass composite element, so two very thin sheets of glass glued to a 3D printed core structure. But why would we use thin glass? Well, actually we are starting using glass with a thickness of 3 or 4 millimeters, but even 6 or 8 millimeters are much more frequently used in practice. And we would like to leave this comfort zone and use 2, 1 or even 0.5 millimeters. This is an even thinner sheet of glass, and it offers us a lot of potential. For example, a very low surface weight or a low footprint on energy, on resources, and so CO2 emissions. But of course, that comes with a challenge. So we have to overcome the high flexibility and unwanted deformation. And this could be one possible solution, the sandwich theory. So we can divide two thin sheets of glass with some kind of core structure or core topology. And by doing that, we increase the overall stiffness of the panel. So with kind of this composite, we would reach the stiffness of about a 15 millimeter solid block. And that is a rendering of our concept behind it. So you can see the two very thin sheets of glass, and in the middle, the 3D printed core structure, which can be adapted to a certain use case, and the adhesive joint, which helps us to reach the sandwich and composite effect in the very end. And in the following, I would like to present a little bit of the production process, which starts with a digital manufacturing process in the very beginning, then followed up by a 3D printing process, the adhesive application, and in the very up, the layering and the lamination process. Well, before we need some preparation. So in case of a curved structure, we need a formwork to print on. And on the right-hand side, you can see a picture right now, which is our robotic system in our laboratory. So a large-scale robot, which we use for almost any task we have to do. This is just a small insight of the digital design approach. So we try to design the core structure and then prepare everything for the printing and adhesive application process, like positioning or the amount of extrusion we use. When everything is prepared, then the production starts with the additive manufacturing. So this is the 3D printing process, and we are extruding here a polyamide with 35% glass fiber content in it. The extruder melts it up with 240 degrees and then deposits it according to the tool path. And in the same manner, we do it with the adhesive application. So that is a hot melt adhesive, which you apply on the same or on the top surface of the core structure. In this case, it is a polyethylene, which melts at around 110 degrees. And then the hot melt cools down and solidifies, like you can see here in this picture, when everything goes right and it looks very nice printed and the adhesive is nice applied. Then finally we can stack the glass on it, and that is a thin sheet glass layer. And if everything goes right in the end and comes out of the lamination process, then we have a thin glass composite element, which you can see here in the picture, as well as a demonstrator just 20 meters behind me. And this in specific is a composite element with a 2-meter radius, and on each side it's a thin glass panel laminated consisting of 0.7 millimeter thin glass, which was thermally tempered by a project partner of us. And the demonstrator shows already the potential and the potential of the concept, but we are still looking for a little bit more to use it as an IGU in a facade. And that are the next steps, but you can see with this slide what potential we could expect when we save that amount of glass. Well, of course, we have some challenges to overcome, for example, in the thermal tempering process. So this was a picture made by our project partners where we have tried to thermal temper a 0.7 thin glass, and you did see the thermal distortion because of the thermal expansion of the glass coming out of the oven. Sometimes the glass fly away in the oven and so on. So there's still a lot to do. Last but not least, we try to explore new design possibilities, like this 3D printed facade inside an airport, a Tiffany store, and I think we can do the next step if we use some thin glass on it to expose it in a different environment in the very end. And with that, I would like to thank you, to the audience, and of course to our institute, to our laboratory, and to our project partners, of course. And yeah, feel free to ask any kind of question or to visit us at our booth or our demonstrator. Thank you very much.